Good evening, freedom lovers. Welcome to the Sysadmin Mini-Conf. Thank you for all coming. Bit louder. Louder? Is this working now? Okay, sorry. Thank you for all coming. We have a reasonably full program this morning and a not so full program this afternoon. The latest version of the program is the one that's online on a page that looks like this one up here. I am sysadmin.miniconf.org. sysadmin.miniconf.org. I am Simon. This is Ewan. We're the two organisers of the Mini-Conf. If you have any questions or whatever, come see us. We're reasonably tight on the program, so we'll let the speakers introduce themselves when they come up this morning, and we'll start off with the first one, Julian, right now. Thank you.
I'll plug this in, we'll see if it does anything. Hello. Don't think so. All right, let me just switch that one. All right. For anyone who's not been to one of my talks before, feel free to shout or heckle. If you're not comfortable doing that, you're welcome to put your hands up and I will try and call on you. It's touch bright up here. And those of you at the back are completely in shadow, so jump, scream, whatever it takes to get my attention, feel free. So I used to be a Debian sysadmin for about a decade. 6 months ago, I moved up to Sydney to work in Google Network Operations. So my day job is managing the network that does that. That's Arbor Network's estimate of Google traffic, historic, and the top graph line there is 7% of the total internet. That's also a couple of years old, and I won't give you what I think of their actual numbers. I'm not here to talk about Google today. This is entirely on unrelated topics, pretty much. If you want to talk about Google, if you want to talk about IPv6, if you want to talk about anything sort of googly, I'm around. Feel free to come and grab me. We have plenty of Google people here. If you want to really complain, we have plenty of ex-Google people here who would probably be perfectly happy to whinge. Yeah, I'm here all week. Feel free to come up, chat. I'd love to do that. So, both being a sysadmin and now working with network teams, our own, the various sysadmin teams at Google, end users out on the planet, there's plenty of... Let me try that. There's plenty of things related to networking that people, sysadmin, don't know and they probably should, or think they know but don't, which is perhaps more dangerous. And knowing these can really help you. They're not necessarily things which will help you every day, but they're things that when you encounter a situation and go, that's weird, why is the network doing something strange? You might be able to look at it and go, oh, that's X. So first up, traceroute. Now, traceroute, pretty simple. Everyone sort of thinks they know what it does. You send a packet out, you send a packet to your destination, TTL 0, wait for it to get rejected, TTL 1, get rejected, and so on and so forth, and eventually you can use those packets to figure out what, in theory, the path is from you to the destination. At some point, your destination responds and you've got your path. Now, that's all wonderful. It's just a shame it doesn't really work like that. In practice, there's a lot of things that can break traceroute. Some are quite obvious. Some are very subtle and you wouldn't know them unless you were aware. So, MPLS. This is a technology that you really don't need to understand. Most networking people don't understand it, even those that run large MPLS networks. Just the arguments we have at work are hilarious. But just understand that MPLS is a technology used by many large enterprise networks and pretty much every large carrier network on the planet. And some configurations of MPLS can break traceroute. This is why you sometimes see a collection of stars in your output, or why sometimes you see a big skip in your output, depending on how they've configured it. Other tunnels, again, if there's a GRE tunnel, an IPIP tunnel, VPLS, IPsec, they don't decrement the tunnel, they don't decrement TTL over the intervening hops, and so they quite regularly are seen as big skips. So if you see a big jump in round trip time that's not associated with an undersea link, for example, that's often a tunnel. Multipath. Many people have seen when they do something, use a tool like MTR, which runs an ongoing trace route, that various hops get doubled, and sometimes the output just gets weird. That's usually caused by multipath, which is when, depending on exact packet details, a packet from you to someone else takes multiple routes. This is really common. Most, again, large carrier networks will do tricks to make traffic take multiple routes. And those routes are not always the same length, they're not always the same time. Anycast, and I'll cover Anycast a bit later. You might not actually be tracing to the same place as somebody else or from somewhere else. Just because an IP address does not represent one single machine necessarily. Multi-homing, slightly less severe than the previous one, but my path may traverse different ISPs than your path. And the reverse path. If you're trying to figure out why traffic from you to someone else is not getting through, a forward trace route may work fine. It's only on the reverse path that you might find the problem, and you can't determine the reverse path. There are various reverse trace route tools out on the internet. Don't trust them. Every now and again we get tickets at Google that you've got this problem and you're going via level 3. Well, usually what happens is they've run a particular reverse traceroute tool which lets you type a host name and it'll do a traceroute from the tool to you and from you to the destination and assume that this host is in the middle, which is pretty much completely useless. So all of those can block traceroute. There's a particularly good Nanog presentation. Unfortunately, I was going to have URL shorteners, but my personal server's down. If you look up Nanog, which is the North American Network Operators Group, recently, a couple of years ago, at one of their conferences, Richard Steenberger gave an hour-long presentation on explaining traceroute and how these various different things can interfere. This is given to an audience of network operators, so the fact that it takes an hour should give you an idea of just the subtleties that really can be involved here. He also goes into a bit of using traceroute to do some level of reverse engineering of carriers' networks. MTU. So MTU is the maximum size of a packet that can be sent on a link or path. On Ethernet, which the world is almost all Ethernet but still not quite, the payload MTU is 1500 by standard. Anything that has smaller or larger MTU on an Ethernet physical is not Ethernet by spec definition. And that's payload MTU, the actual physical MTU, depending on exactly which frame options you use, about 1536. And that's bytes. So it matters because a smaller MTU means greater overhead. Back in the day of dial-up, MTUs around 536 were common. These days, research networks are often using MTUs of 9,000 or 65,000, which is 64K bytes in binary, is the maximum packet size for TCP and most link protocols. A smaller MTU limits the throughput. It's a lot more complex than that, but the limiting factor with a lot of transport technologies is actually the number of packets in flight, more so than the number of bytes in flight. And the really ugly one is if you decide, I want all these benefits of a large MTU, I'm going to increase my MTU. You need to increase it on every device in the subnet, or you're going to have a problem that will drive you insane. And this can be really fun when it's a network that involves 3 parties. It's quite often seen on internet exchanges where somebody will increase their MTU, the intervening network may or may not transport it and the remote end doesn't. That's 3 parties, none of which want to give any information to the other side. Really fun to diagnose. And when it is small, when you have a big packet running into a link with a smaller MTU, you run into packet fragmentation, which can be very slow on most modern routers because they've just removed the optimizations for it. Or, if you're running into someone who thinks ICMP is evil, you get the packet drops. You get packet drops which aren't notified because somebody's blocked ICMP. Now, why would your payload MTU ever actually be smaller these days? Because we don't really have dial-up. Unfortunately, we have the wonderful thing called broadband access networks. That, in this sort of rough diagram of your computer over a DSL network, you've got your PC on the left connecting to your local router. Personally, I think anything that 2 people can lift is not a router. I'm kind of biased. But your customer premises equipment, NAT router, whatever you want to call it, connects over fibre or over phone lines to an aggregation box, a DSLAM or an OLT. You then have this cloud of an aggregation network. You then have an ISP router and potentially an ISP cloud, and then you have the internet. So the bit in the middle is the access network. And so this matters quite a lot because these networks are really hard to troubleshoot when they go weird. They're usually layer 2 or sometimes very simple layer 3 networks, but because they're tunnels, they're incredibly opaque, and even the people who run them can find it hard to troubleshoot. They're often not monitored or managed as well. People sort of rely on the fact that they monitor the traffic going over them. And this is exactly how the NBN is going to work. So it's not like this is going away, it's actually going to get more pervasive. And they're tunnels, so they often cause MTU issues. Unfortunately, people often fix the MTU issues. Cisco particularly have a IPTCP fix-up command, which will transparently fix TCP sessions to shrink the MSS, which is the TCP version of the MTU. Unfortunately, in at least one large Australian, or fairly large Australian carrier who's mentioned on this stage, they don't do that for IPv6 and they don't have their MTU correct, so things work very well. And this took several of our engineers small time over multiple days to figure out exactly what was happening. It's a real pain to deal with these networks when they go wrong. Anycast. So as I mentioned before, one IP does not refer to one specific machine. It's perfectly valid, admittedly a little weird, for one IP to source from multiple locations. In this example, you've got one user on the bottom left, one user in the top right, 4 different ISPs, and the 2 router nodes symbolize Anycast sources. So all that means is the one on the top right goes to the node in the middle right there, the one on the bottom left goes to the middle left. The idea being that you will, by virtue of optimized routing, hit the node nearest to you. It's basically safe to use with stateless services like DNS, or at least UDP DNS. 12 of the 13 root server implementation, DNS root servers use it. The remaining is run by the US Department of Defense and is the only root server to often have outages. And most of the public DNS services, a la OpenDNS, do this as well, so that they can give you one IP address and you'll just end up at the nearest serving location. It's not great to use with a web server, although you can, because should the routing change on the network, which really does happen hundreds of times a minute even, you could end up at a different node and your TCP session would die. And if the routing state is not stable, you then bring up a session to the new node and you flap back to the old node. So the solution to that is to use, if you're using Anycast, you use it to run DNS, which then combines with IP geolocation to tell you, basically to point you via DNS to the next serving node, which is just served normally. IP geolocation is essentially a database. Big ugly database of, here's an IP subnet, here is where I think it lives on the planet. Quite simply, here's some of my own. I think 188.0/22 lives in Melbourne, except for this subnet which lives in Sydney. And that's all it is. There's a variety of ways you can mark an IP as actually more accurate. I could mark those down to the meter in that case, but most of the geo database providers only care about city, if not even state or country in some levels. And yeah, so what? So use it. You can use it to show relevant information, ads, whatever, to web users, and to send users to their nearest cache or serving location. In Debian at least, all the packages and source data are now actually available in the repository. So you can do this fairly easy without having to go anywhere. And if you're an ISP, if you're an enterprise, and your users are continuously getting sent to Google Ecuador or get ads for porn sites in another country instead of local porn sites, fix it. There are two main providers. MaxMind is the provider that almost everyone on the planet uses, and Google have our own database, because we're Google. Let them know there is, if you search for information, you'll find out quite quickly on how to get geolocation databases updated. Unfortunately, for Google at least, these requests take a couple of weeks. For MaxMind, I don't know how quickly requests get updated, but with MaxMind specifically, users often get a copy of the MaxMind database, so until they've updated, you're still out of date.
I'm told it takes a week or two to get updated in the database, and then most people get the 3 monthly dump off the database.
Yeah, so there we go. A couple of weeks to get updated, and users update quarterly-ish. Some quite literally would get a copy and not touch it for years. This used to work quite nicely back in the day because the default is almost always falls back to US, North America, and that's often close enough to what you want that it's fine. Sadly, now that IPs are getting recycled quite regularly, I in fact had a block. I was in the middle of returning to AppNick only for it to get stolen for the final China Telecom allocation before I'd finished giving it back, which was humorous. Yeah, so the earlier you send the ticket response, the fewer months you're going to have to listen to users whining. Now, second last one, NAT is not security. Flat out, NAT is not security. Now, this is actually got some slight subtleties to it. By definition, a stateless NAT cannot be security because it has to let arbitrary packets through. Now, a stateful NAT is simply adding a translation rule to a stateful firewall. So there's nothing really special about the NAT there. And the fact is, NAT traversal has established to the point where through most firewalls, at least those not specifically trying to block all outbound connections, through most firewalls you can now basically have an arbitrary server listening. It's not hard. And just for all those who say you've got to have NAT, there are no generally required security protocols practices that require NAT. PCI doesn't now, it used to. HIPAA, Sarbox, all those, none of those require NAT. You may have to hit your auditor with a phone book a couple of times to get them to agree, but there is no requirement for NAT in those scenarios. This also is about to get very weird as we start running out of IP addresses in general, and ISPs start running NAT as well with carrier grade NAT. Now, probably won't affect much of us because we're the sort of people who run business class connections at home, and they're going to be safe for a while. But your average home user within a couple of years is going to start being behind their NAT router that connects to the internet and the ISP's NAT. And there's nothing you can do about it. None that I'm aware of in Australia, other than the various 3G, some of the 3G networks. But to date, the 3G networks I'm aware of in Australia that use NAT, in fact use stateless NAT, and they give you a private address so they can do many-to-one mapping, but they currently map one-to-one. And a corollary on that, private IP addresses are not secrets. If you use RFC 1918, 10/8, 192.168/16, 172.16/12 addresses inside your network under the theory that even if someone gets access to them, they still won't know my IP addressing, it leaks. Google has an internal IP addressing plan. It leaks. We have people doing a lot of work to ensure it doesn't leak. It still leaks. And if you're going, we have private addressing so it's unroutable, that leaks as well. Many carriers use 10/8 internally. Some of them even use steal public space internally. Experiment with sending packets, you'd be surprised how far you can go. Now, lastly, IPv6. It's, at this point, a complete cliche to say, you should be running IPv6, it's wonderful. And admittedly, we're running at the conference, and what happened the first time we try and use it? Well, it's broken because someone's got a badly configured machine on the network and it's spewing lies. That can happen with IPv4 as well, we just don't see it as often. So, I'm not going to tell you to deploy it. You should. It really isn't that hard. At least these days, pretty much every vendor that matters has fairly good v6 support, except for Cisco and a bunch of their products still. If you're trying to run IPv6 in a Cisco data center, I'm sorry, you should have thought better.
If you provide this new IPv6, that doesn't help though.
Yes, sadly there are still providers in Australia that don't do v6. At this point, for everything but ADSL connections, I think almost all of them do v6. You may still have to ask about it specially, but it is, at this point, it is pretty much standard.
In Germany, there's no provider you can get that does IPv6.
I will bet you that you're wrong, but admittedly, it's probably, you have to spend a lot of money. Yeah, so consumer connections, I completely agree, it's still really hard to do. And you just heard me whining about tunnels for several minutes before. So while IPv6 tunnels work, they're ugly. If I had another 3 hours, I'd explain about how the various carrier IPv6 deployment mechanisms and why they're going to work, probably, but they're just horrible. Oh, and all those people who still like blocking ICMP despite the fact it's wrong and evil, if you try that with IPv6, you won't get a working connection. So please, if you're going to block ICMP, block source route / explicit route, that's it. But the thing is, you really are already running IPv6. If you're running a generic LAN without specific port security / port isolation type filtering, you will have IPv6 traffic on it. Dump a sniffer on a general access network, particularly one that's got Apple devices of any sort on it, or printers or a couple of things, and you will have v6 traffic. This is not new. This has been going on for a while. Rendezvous, multicast DNS, most of this stuff, games, use IPv6 because it works with no configuration. I was at a LAN party 15 months ago or so and did a sniff of the network. They were running about 10 megabit of broadcast multicast traffic, fairly big LAN party. About 1 megabit or so was v6 broadcast traffic. It really is out there. And if you're relying on the fact that you don't run v6, we had an example last night of how we don't run it, we're safe, is stupid because somebody with a tunnel, somebody with a Linksys box suddenly turns on v6 silently or automatically establishes a tunnel. and everyone's running it, and oh look, it completely bypasses any firewall and security mechanisms. Just think about it. If you really don't want to run it, you actually have to block IPv6 on your switches and deactivate it on machines. It's the only way to actually have any faith, have any plausible faith that you're not running IPv6. Because otherwise, you are running IPv6. You just might not be able to talk to anyone outside of your LAN. So that's pretty much it. Any questions if I've got any time? Yep.
Do you think that ISPs who are going to start manning their users are going to do that before they actually assign IPv6 addresses?
So IPv6 carrier grade NAT, basically carrier grade NAT is people putting their head in the sand and hoping the problem will go away. There are ISPs who are using it as an assumption that NAT is easy. This basically comes from people not quite understanding the concept that stateful devices in networks, in large networks, always break. This is why enterprise people who go into service providers often have a really bad time, because they'll go put a firewall at the edge of the network and it promptly melts. There are people who will be using carrier grade NAT to still give their customers almost usable IPv4 while they've got IPv6, but just not everything's using it. That's not so bad, because the users will still have a direct path to the internet, and probably even more direct than they used to. But ultimately, management inside the ISP space is fairly horrible in general. You've got some really good people. Sadly, it's often people who were really good 15 years ago and have now been management and just have not caught up. There's nothing, there's no simple answer to that one, really.
Julian, can you expand on the point in the traceroute slide when you talked about traceroute in the reverse path, and you said that going on to looking glass sites, site feeds like in the address and traceroute back to yourself is not a particularly valid method?
Okay, so various reverse traceroute methods. If you're just going to a website and having it do a traceroute back to you, that's valid for that connection from that website. There are tools which claim to give you the path between you and some other website. Those are the ones that are particularly invalid, and that was what I was referring to in general. But yes, as long as you recognise it is the path and possibly not the complete path between that device and you, that's okay. We time? Okay. As I said, feel free to come and grab me if you want to talk about Google things or this or time. Thank you very much.